වසන්ත ඇහෙනව නේද? හරි නේද?
yes yes එහෙනම් හරි එහෙනම් නදීරනේ hello
වසන්ත ඇහෙනවද?
ඔව් මං කියන එක ඇහෙන්නේ නැද්ද hello
දැන් හරි වසන්ත. දැන් හරි.
hello
ඇහෙනවනේ? හරි. ඔව්. ඇහෙනවනේ? වසන්ත
එහෙනම්
ඇහෙනව නේද? හෙලෝ.
yes එහෙනම්
හරි හරි හරි. එහෙනම් හරි. එහෙනම් හරි. මේ මම ඔයාව ඉන්ට්‍රොඩියුස් කරේ මේ ඩොක්ටර් චන්දන කියන අපේ ඩිපාර්ට්මන්ට් එකේ අපේ මේ ෆැකල්ටි එකේ තව ලෙක්චරර් කෙනෙක්. ඩොක්ටර් චන්දන ඇහෙනව නේද?
ඔව්
ඔව් මේ නදීර එනවා.
හරි හරි. මේ ඒ කිට්ටු වෙලා එහෙනම් ඔයා මේ ප්‍රසන්ටේෂන් එක
මේ
අප්ලෝඩ්
නදීර මේ
කරන්න.
මට ස්ක්‍රීන්
ඔයාට ස්ක්‍රීන් ෂෙයාරින්
මේ
තියෙනවනේ
ස්ක්‍රීන් ෂෙයාරින්
නැද්ද?
ඔව් allow කරලානේ තියෙන්නේ
allow කරලා තියෙන්නේ විනාඩි
ඔන්න බලන්න මම ෂෙයා කරන්න
හරිනේ.
හරිනේ
හරි හරි.
පේනවනේ
හරි හරි හරි. අවුලක් නැහැ අවුලක් නැහැ. හරි.
හරි හරි ඕකේ
හරි එහෙනම් අපි කිට්ටු වෙලා පටන් ගමු නේ. තව වෙලා තියෙනවා ටික විනාඩි 20ක් විතර මම නිකන් ඔයාලට
හරි
ටයිම් එක දෙන්න හරි හරි හරි.
ඕකේ ඕකේ
Mr. Vasantha, can you hear me?
Yes, yes, I can.
Yeah, okay, fine. Okay, good afternoon, everyone. I would like to welcome all of you on behalf of our 2023 organizing committee, especially Mr. Vasantha Perera, who is our resource person for today's session, and all the participants who are now logging for the session. I hope we can start today's session at this moment. Before that, I would like to give a brief introduction about our today's speaker, Mr. Engineer Vasantha Perera. Now, actually, Mr. Vasantha Perera graduated from University of Toronto in 1999 as a civil engineer, and then he joined as a civil engineer at the Center in 2000. And again, he obtained his master's from same university in 2009, and again, he's a chartered engineer of Institute of Engineers Sri Lanka, and he is a member of Society of Structural Engineers Sri Lanka. And presently, he is the head of the Department of Civil Engineering in NERD Center. We know that NERD Center is it's a very prestigious institute where they do a lot of research and they introduce new technologies to the construction industry. Therefore, we believe that your expertise in those areas will benefit for our students and all the academics and other people who have joined for this session. Definitely, we will think this will be a very interactive session. With that note, I would like to hand over the session to Mr. Vasantha Perera, who is the head of the Department of Civil Engineering in NERD Center. Over to you, Mr. Vasantha.
Thank you, Dr. Nadira. I will share the screen now. Can you see the screen?
Yes, Mr. We can see.
Okay. Today, I am going to discuss you the innovative and sustainable technologies introduced by NERD for the construction industry in Sri Lanka. Actually, under this topic, I discuss not only building construction technologies, but some other civil engineering related technologies introduced by NERD. My content, a brief introduction to NERD Center, and mainly NERD cost-effective building construction technology. Under this building construction technology, I will explain the foundation system, pre-stressed concrete columns, cost-effective wall construction methods, cost-effective floor set construction methods, other precast concrete components, and some of our past projects. And other technologies, under other technologies, I will tell you about pre-stress and post-tension masonry retaining walls, and pre-stress and ferrocement bridges.
Yeah, when we're doing leveling, yeah. Only thing, I am in a session now. Can you come in about half an hour? Okay. Sorry about that.
Other ferrocement products. Shall we move one by one? NERD Center, it is commonly known as NERD Center, but its full name is National Engineering Research and Development Center of Sri Lanka. It is established in 1974 by Industrial Corporation Act, and presently it is located at Industrial Estate Ekala Jayala. And our total workforce, including skilled and unskilled laborers, is around 300, and we have nearly 40 plus engineers in all disciplines of engineering. And we are now under the Ministry of Education. And we move on to the cost-effective building construction technology. We have entire system. We have introduced alternatives, and actually, some of these techniques are introduced by late Dr. A.N.S. Kulasinghe, who was the chairman at NERD in its beginning. And some engineers joined NERD Center. After that, added some more technologies. If we consider the foundation system, we know normally we are familiar with trouble masonry foundation, what is shown in this picture. And instead of this, this is very expensive and it needs a lot of excavation and it needs a lot of material, rubble and cement and mortar. As an alternative, we introduce a small plinth beam, rest on ground and spanning between columns. And above that, we construct a plinth wall. It is made out of cement and corridors mix, 1:10 ratio. And you can make the difference between the existing ground level and the finished floor level with this slip form plinth wall and plinth beam. This is the foundation we introduced. The size of the plinth beam varies depending on the ground condition and the load of the wall, etc. This is the drawing of a foundation. You can see this foundation plinth beam rests on these two columns and it is supported by the ground. And in this case, it is 4-inch height. And we construct a plinth wall on top of that with cement and corridors to make the relevant floor level height. This is the foundation we talking about. Then we don't need excavation in this area between two columns. We can eliminate excavation. These are some pictures of the foundation. This is a small building. This is another one. For this plinth beam, you can introduce reinforced concrete beam as well. If you consider the uneven settlement, etc., you can design for that. And same thing we can use for the foundation. And you can construct the plinth wall on top of that. This is the foundation introduced by NERD Center. And these are some pictures. This is a column excavation and you can see the reinforcement ready for the plinth beam. This is how we put the plinth beam. Here we have used 2 number of reinforcement and on top of that, this is the plinth beam. On top of that, we construct plinth wall. This is reinforced concrete. This is 1:10 cement and corridors wall. It is we call it plinth wall. This is a foundation during construction. And the limitation of this foundation is you can go up to maximum of 1.5 feet. That means that level difference between the existing ground level and the finished floor level is more than 1.5 feet. You have to go for the traditional technology because this slip form plinth wall cannot resist the lateral force by the soil, given by the soil. And instead of traditional reinforced concrete columns, we have introduced pre-stressed concrete columns. Partially, actually, these columns are not fully pre-stressed. These columns are partially pre-stressed. These are the columns. These columns are made out of grade 40 concrete. You know, if you are using pre-stressing, the maximum grade minimum grade you can use for pre-stressing it is grade 40. It is given in the code as well, BS code. We produce columns of sizes, section 4 by 4 inches, 5 by 5, 6 by 6, and 8 by 8. We can produce even bigger sections, but the problem is handling is difficult. Most of these precast components, precast concrete components, we handle with manual labor. These 6 by 6 column we can erect with the help of 5 or 6 labor easily. If you use a boom truck or excavator, you can erect even 40-50 number of columns within a day. These columns, there are connection arrangements for these columns, connection of foundation and connection of the next level column. I will show you by pictures. These are the connecting arrangement. In one column at the top, we put this 25 millimeter toe steel bar. In the other column, we put a 32 millimeter GI pipe, and we fill this GI pipe with cement paste and fix the column. This is the fixing arrangement. This is the fixing arrangement for at foundation level. We have two methods. This is first method. This is the traditional RCC column. This is the prestressed concrete column fixing arrangement I explained. You can see up to ground level, there is in situ column coming. And you have to keep a GI pipe in the in situ column, and you manufacture the prestressed column with the GI pipe with the 25 millimeter toe steel bar. It is extended out of the column 2 feet and inside the column 2 feet. And we fill this GI pipe with cement paste and fix the column and keep it vertical and support it and keep it for a day. Following day, you can remove the supports and column is fixed. This is one method. This method is suitable if the ground level is not flat. You can make all the columns up to or ground level with this in situ column, and you can fix the prestressed column on top of that. Then you can eliminate the ground differences. But this is little expensive because of this 25 millimeter toe steel bar. Toe steel are very expensive. Then this method is expensive than the method 2. This is the method 2. Here we don't use this toe steel bar. What we do is we cast the in situ concrete base and we place the prestressed column on the base like that. This is the prestressed column. It is on the base, and we concreted it using there is reinforcement coming from the base like normal column and shear links, and we insert the column, prestressed concrete column, and concrete this stub column. This is the method 2. Depending on the site condition, you can use either method and do the construction. This column, 6x6 columns, can withstand axially near 225 kilonewtons, and 8x8 column can withstand 400 kilonewtons. These 4x4 and 5x5 columns are used for small single-story construction, small water tanks, etc. If your loads are higher, you can go for higher sections, but the problem is handling. If you have machineries, then you can manufacture columns with higher sections. This is the column erection. We make the concrete footing and put the reinforcement for stub column and place the column in line and in vertical way. Then fix some support, and you can concrete using this formwork. Then following day, you can remove the formwork and column is completed. Like that, you can erect all the column of a building within one day. And these columns are cheaper, over 30% cheaper than the traditional RCC column. And since these columns are manufactured at a pre-stressing yard with a good supervision, the quality of the column is high. When we do construction at site, no supervision most of the time, and honeycombs and verticality. There are a lot of issues. You can eliminate most of these issues with these columns, and these columns are durable because these all are made out of grade 40 concrete. Normally we use grade 25 or grade 20 for RCC construction. And cost-effective wall construction methods. NERD Center introduced 2 wall construction methods at commercial level. There is another construction method not yet introduced to the commercial level. I discuss only the commercially available technologies. The first thing is cement stabilized soil block. That's a SLS standard also for this block. The advantage of this all this whole construction system is it use minimum amount of sand, sometimes no sand. In this soil block wall, no sand is used, only soil is used, and these are interlocking blocks. Then you don't need mortar to make the wall as well. First thing is you have to select a good soil. For this soil block manufacturing, mainly you need gravel soil. If your soil contain more than 60% of coarse sand and gravel, and content of silt and clay is less than 40%, that type of soil is suitable for manufacturing of cement soil blocks. You can use a simple test, this bottle test, and what you have to do is you have to put the soil sample at half level of the bottle and shake it well and keep it to settle for 24 hours. Following day, you can see at the bottom, you can see the gravel. Above that, you can see the coarse sand, fine sand, clay, and water, like that. Then you can measure the height of these individual layers and calculate the percentage. If it is calculate this equation, then that means this soil is suitable for manufacture cement soil blocks. Normally, simply gravel soil is suitable. This clay particle size distribution, this clay, what we consider less than 0.002 millimeter, fine sand between 0.02 to 0.075, sand 0.075 to 5, gravel 5 to 10. And to manufacture these soil blocks, we have to sieve this gravel soil. We have to sieve using 6 millimeter sieve. That means if the particle size is more than 6 millimeter, the finishing is not good enough. These are manual, normal sieving methods, and there are some mechanical methods also. You can use either method and prepare your soil, and you have to mix it cement. Normally, there are 2 machines. We use 1:10 to 1:15 ratio. These are manual methods of mixing and automated methods also. You can use either method. And when you adding water, you have to be careful. You can't add water like cement, sand, mortar. We use this what is called this bucket, flower bucket, to add water and mix well. Otherwise, it will not properly mix. And then you have to manufacture the soil. There are different type of machines we have introduced. Vibrated type means the normal block making machine. Fan type machine are the machines specially introduced for manufacturing of these blocks, and compressed type blocks. This is normal block making machine. You can produce blocks, but the problem is the finish is not sufficient to keep it exposed. You need to plaster it, but still it is cheaper because this sand or corridors is replaced by soil. it is sand, soil is cheaper than sand, then this is blocks are cheaper. This is we introduced this system for North and East, this housing rehabilitation project. This is one model house constructed near Omanthi. This is in 2005, I think. And using these hand molds also, you can manufacture these cement soil blocks. Then you have to use 1:10 because the compaction is low with compared to hydraulic machines. And if you have your own construction, you can use this type of hand molds. This is another type of hand molds. This two C channels and timber dividers, and you can using this equipment you can manufacture soil blocks easily. And there are some machines, compressed type machine. We have introduced some machines. You don't need electricity for this machine, this type of machine. We can produce 300 to 500 blocks per day. And plastering is not necessary. Blocks have as good finish, only manpower is required. These are the machines. This is one machine. This is another machine. All these machines are introduced by NERD Center, and we have now transferred the technology. There are manufacturers. There are few manufacturers in the country who produce these machines. These are the blocks manufactured using these block making machines. These blocks, after manufacturing, you have to cure with water for at least 7 days, same as because cement is there, normal curing is required, and you have to cover it with a polythene or something, keep it for 28 days before using on walls, allow for shrinkage. And with these small elements, you can make half blocks, lintel blocks, etc. And with this one, you can make a hole. Then you can have additional reinforcement if you need, or you can use this hole to insert conduit pipes. And if you wish to manufacture soil block as a business, the best thing is to go for a hydraulically operated compressed block making machine. Then you can use the cement soil ratio 1:15. Earlier machine, you have to use 1:10. Now with this machine with this high compression ratio, you can use 1:15. Then it is cheaper. With this machine, 180 blocks can be manufactured per hour. The finish of the block is very good. Easy operation. 2 blocks can produce at a time. This is the machine. We have 10 to 15 registered manufacturers all over the island. Some manufacturers have the capacity to construct, has to fabricate 5,000 blocks per day. Lanka Ecobricks and several names, they manufacture, they have such a capacity. This is one of our registered yard. They have enough stocks. You know, nowadays construction industry has some problem. Then they are also facing the problem of selling these blocks. This is the house constructed by the owners. The owners manufacture the blocks and they construct their own house. This is another house with soil block. This is the building at NERD Center. This is our business development center. There are some model house also constructed at NERD Center. If anybody want to have a look at these houses, there are few model houses constructed at NERD Center. Anybody can come in a weekday and visit these buildings. Advantages, these blocks, you don't need sand. Then it is a solution for sand crisis. environmental friendly because sand mining is minimized. Soil is freely available, less transport problem with compared to sand. Comfortable environment inside the house because heat transfer through this soil block is minimum. The technology is simple. Significant amount cost can be saved and it will create new employment. And next wall system is the slip form wall. Actually, this one is introduced by Dr. Kulasinghe in 1980s. At the time of introducing this corridors is a waste from the quarries. Then he introduced this wall construction methods. This is actually load-bearing wall. You can put a slab without these RCC columns. This is a load-bearing wall. Here we use cement and corridors 1:10 ratio. Water cement ratio we use is 0.35. You don't need mason to construct this wall. Here you need this slip form shutter. Slip form shutter is a slip mean it is this shutter is made out of steel and there are two brackets like that. And the shutter we put at the bottom like that. And we fill the inside with cement and corridors mix 1:10. And using this ram, we compact. And using these two hydraulic jacks, we keep this hydraulic jack here and lift the shutter. And fill the shutter again, compact again, lift again. Like that, you can continue the wall up to the top. Continuous construction. You don't need to wait after construction 5 feet like that. You can complete the wall if your wall height is 15 feet. It doesn't matter. You can continuously construct. If there are openings, what we have to do is, if there is a window or door, you have to keep the frame inside the shutter, and two sides you have to follow the same procedure. Then you can like this. Here you can see the window frame is placed, and two sides we fill with this mix. And if you need the lintel, you can cast the lintel with the same shutter. Like that, you can complete the construction at the top. If you need a tie beam or something, you can cast the tie beam using the same shutter, and following day you can remove the shutter. This advantage of this one is this is not block by block making method. This is entire wall is like a single block. Then you don't need to plaster. You can directly apply lime putty or this coat or something. You can apply and get a smooth finish, like a finished plastered wall. And that is for the inside. Outside, you can just directly apply the weather shield paint and this filler or waterproofing seal or something. Then this one also no sand is used. This one, earlier one cement and soil. This one cement and corridors. In these two methods, both these wall construction methods, you don't need plastering. That means this wall construction method, we have eliminated plastering. You can save sand. These are some buildings we have constructed. But nowadays, this cost of this corridors is little expensive, but still it is cheaper than the sand, and still this technology is viable. We will use this technology still in our projects. And this slab construction also we have introduced some technique. It is also introduced by Dr. Kulasinghe and later modified by some engineers. It's a traditional slab system. No, if you design RCC slab, if you apply the deflection control, the slab thickness is around 5 inch, and you need a lot of formwork and supports and a lot of reinforcement. And as alternative, we have introduced this slab system. Here we use faceless concrete beams at 2 by 2 feet interval and a plywood formwork of ferrocement panel and no toe steel reinforcement, only a 2 by 2 GI mesh and 2-inch thick in-situ concrete topping. Then you can have this type of slab. It is also cheaper. There are two systems. One is with the plywood one. This is a ferrocement panel. This is a permanent panel. I will explain both. In this subsystem, you have placed precast concrete beams at 2 feet interval and 2-inch thick in-situ concrete topping. These beams are pre-stressed with 3 number of 5 mm high tensile steel wires. Each wire is tension to 20 kN and grade 40 concrete is used. And we use for the in-situ concrete topping, we use gauge 10 2 by 2 GI welded mesh. And the beam depth varies depending on the span. Maximum span you can have is 6. We have a small mistake. This is 16 feet. Maximum span you can have with this slab is 16 feet. That means if your panel size is 16 by 100, it doesn't matter. You can have 4-inch D beam and you can construct the slab. This is one slab system. Actually, this is the system introduced by Dr. Kulasinghe. These are pre-stressed beam at 2 feet interval. This is the in-situ concrete topping. At the center of the in-situ concrete topping, we have a 2 by 2 GI welded mesh. But the problem is you need a plywood formwork here. Then the house owners facing some difficulties in finding this plywood formwork, and later other engineers, they introduce a ferrocement panel here. The beam make with a small groove like this, and we place the panel here, and we put the in-situ concrete. This method is easier than the earlier method, but this method is expensive than the earlier method. Earlier method, plywood can be reused. This ferrocement panel is a permanent formwork. It cannot be removed after you place it in this in-situ concrete topping. These are the two methods introduced by NIRD Center. Actually, this slab is designed in accordance with the clauses and guidelines given in Chapter 5. These are some pictures. These are the beams. This is the in-situ concrete topping. These are the ferrocement panel. We use these fiberglass molds to manufacture these panels. These panels are made out of ferrocement. Ferrocement means cement and sand with some mesh. Here we use gauge 18 1 by 1 inches GI mesh. This panel is there to only to keep this in-situ concrete. This is not actually, this panel is not a structural element. It is a permanent formwork. After the concrete is set, this panel is not required, but we cannot remove it. Then we have a design at the underneath of the panel. Then you can have this type of finish. There are some plain panels as well. Advantages of this NIRD composite floor slab system. Actually, this is a composite system. This is composite system of pre-stressed concrete and in-situ concrete topping. Pre-stressed concrete beam and in-situ concrete topping. The advantages: considerable reduction in weight. You know, it's 5-inch thick RCC slab. Yeah, unit weight is 3 kilonewton per square meter. In this slab, it is 1.8 self-weight is 1.8 kilonewtons per square meter. Then significant reduction of self-weight. Then you can reduce the foundation as well, because the self-weight is one of the most significant weight when you consider the foundation. Then this with reduction, you can reduce the foundation cost as well. Then no propping is required. Then if you put the normal slab, your props cannot be removed until 28 days. Then with this one, since there are no props, the following day you can start the internal finishes of the room. And this is cost effective, it saves material. These are the advantages. Few limitations. This pre-stress technology, it needs special knowledge. These beams can supported only in simply supported manner. And it required pre-stress beams. Pre-stress beams can be manufactured at the pre-stressing yard. And there are some limitations of span and limitation of imposed load. And you cannot construct wall without the underneath beam. If you want to construct a wall on the slab, you have to put the RCC beam below the slab before you cast the slab. These are the limitations. Then other precast concrete components, this is very familiar now, concrete door and window frames. First introduced by NAD Center, now it is very common everywhere. Then I won't explain it further. And these staircases are very expensive. Then this labor cost is expensive. We introduced this precast concrete staircase. There are two stringer beams and L-shaped steps. With this arrangement, you can fabricate this type of staircase, fully precast, and very cheap, over 40% cost saving. And there is a spiral staircase also. This is not good for the main staircase of the building. It is good for fire exit or as additional staircase. But this one, the stringer beam and L-shaped steps, it is suitable for the main staircase of the building. And we have roof trusses, steel. This is cheaper than 50% cheaper than the steel trusses. The maximum span you can have is 40 feet. These trusses are pre-stressed. And these are some buildings we constructed. This is Milco Industries stores building at Polonnaru. We renovated this building recently in 2021. Earlier there was a timber frame. We replaced this timber frame with pre-stressed concrete trusses. These are some past projects we have done. This is a model house at NAD Center. If you visit the NAD Center, you can see this model house. We have used this staircase, soil block wall, column, slab, all our technologies here. It is available for public visit. And these are the library buildings we constructed with the Presidential Secretariat in 2012 to 2014. It's parallel to data curriculum. We have constructed over 70 buildings in Monragala, Anuradhapura and Hambantota with the help of Civil Defence Force. We train Civil Defence Force soldiers and they construct these houses. Because this technology is simple. Within a 1 or 2 day training, anybody can acquire the technology. And Vidata centers, we have constructed a lot of Vidata centers. Almost all Vidata centers in the country constructed using that technology. Haliyala, Pannala, Giriyala, Madampi, Hadawata, Sandilipe, Nallur, Saindamarudu. This is in North Province. And this is one building we constructed at Ekala Air Force Camp. This is Galway National Park quarters building. All our technologies are used here. And this is Wataraka Junior School. This is a clinical building at Wadwa we constructed in 2015. MOH Dodangoda, Kadukka. And this is one of our latest building. This is MOH building Wadwa. We just completed this building in this year, not yet handed over actually. Total floor, this is three-storied building. Total floor area is 15,000 square feet. And the project cost is 72 million. We use all our technology here. And this is another building we completed in 2023. This is at Faculty of Indigenous Medicine, Rajagiri. Here, this is a lecture hall building. Here also we use combination of normal RCC column and pre-stress column because the lecture hall imposed load is higher. This our pre-stress concrete columns cannot withstand these loads, so we use in situ concrete columns, and our slab and soil block and roof trusses are used here. Staircase, this string beam and L-shaped step staircase also used. Here we completed only the third floor because their budget is limited and the project cost is 69.6 million with price fluctuation. We started this building in 2021 under this during this crisis, and we completed recently. And in our estimate earlier first estimate is around 47 million, and we end up with 69 because of this price increase. And now it is handed over the lecture hall, and lectures are conducted here now. And we introduced pre-stress concrete retaining walls instead of traditional retaining walls. Traditional retaining walls are made out of rubble masonry or reinforced concrete masonry. And these are the system we introduced. These pre-stressed concrete wall panels are produced at the pre-stressing yard, and we put the foundation and fix this column vertically. And these columns are pre-stressed so that this lateral soil pressure can be handled by this pre-stressing. This is the sketch of the drawing. This is a normal foundation, and this stub wall is RCC, and we fix the column pre-stressed concrete wall panel here. You can see, you can understand easily with these pictures. Excavate, and we put the base, normal design, and we construct the wall up to the ground level, and we manufacture the pre-stressed concrete panels, and we check the chamber whether we can check whether pre-stressing it is applied to the concrete. And we place the panels, and we fix the panels with this anchor bolt to the in situ concrete wall. You see, it is below the ground level, and keep it vertical and put the formwork and concrete. Like that, we can go up to 12 feet height. This section of this column is very small. I will show. And we check we fill the top side and bottom side, and we check the deflection also, very small deflection. And durability is very high because this pre-stressed concrete is involved. This is a completed project. We have completed several projects all over the country with this pre-stressed concrete technology. These are the sections. If your height is 3.3, your top bottom panel size is 175 by 300. Here you can see top 3 inch, bottom 5 inch tapered wall panel, because the moment is 0 at the top and maximum at the bottom, that due to lateral pressure. And with this one, we cannot reduce cost much because this concrete and steel is involved. Minimizing cost is not easy. Then what we think about this masonry blocks. The problem of masonry block is normal masonry blocks cannot be used because it cannot take lot of compression. Then we have to manufacture special blocks. Normal blocks compression is around, but if you produce post-tension masonry retaining wall, you need 7 to 8 compressive strength. And this same soil block making machine, and we put 1:5 ratio cement and corridors with this compression, we can get this compressive strength with this block. Then this block is suitable in test, direct compression, flexural, tensile, everything, it is suitable. This is the analysis part. This is the pre-stressing. This is the stresses of on block due to pre-stressing and this is due to soil pressure. And this is the resultant. And resultant stresses are within the allowable limits. Then we can manufacture this post-tension mason retaining wall. We manufacture blocks at NAND. And like earlier one, we cast the concrete footing and the wall up to ground level. And we kept holes to insert high tensile steel wires to make the post tensioning. This is the arrangement we use the post tensioning. This is the wall up to ground level. Then we construct the wall on top. You can understand with the pictures. With this PVC pipe, we can make this type of holes, vertical hole and the horizontal hole. This is to lock the pre-stressing wire. And we place the blocks and we construct the wall like that. And after completing the wall, we put the tie beam on top. And there is a small 2-inch diameter hole here. And we insert the high tensile steel wire from the top and put the anchor cone and pin here and fix like that. We can fix the high tensile steel wire. And from top, we can stress the wire using this hydraulic jacks. This is on top of the wall. And then you can pre-stress this masonry wall eccentrically. Because the wall, the hole diameter is 2-inch. Then you can keep the pre-stressing wire to a side and stress. And this anchor cone and pin we cover with the mortar because to avoid corrosion. This one is very cheaper. But the problem is we face some problem. Our machine is developed to manufacture cement soil blocks. Then when we manufacture cement and corridors blocks with this machine, the durability of this machine reduced. That's the problem. This he still cannot solve this problem, but the technology is very good, very cheap. This wall construction method, post-tension masonry. No concrete is involved above ground. And this is 25 to 30% cheaper than the RCC wall. This is a completed project. And in addition, we have introduced footbridge technology. You know, in Sri Lanka, there are around 5,000 unsafe means of 5,000 places in Sri Lanka with the unsafe means of crossing canals. In some places, there are no any means of crossing canals. They have to cross the river through the river. There are this type of methods, timber logs, like that. We did a survey in 2007. We identified over 5,000 places are available. Then we did a research to introduce a cost-effective footbridge. And finally, we introduced 2 technologies. One is ferro-cement technology, other one is pre-stressed concrete technology. Now we have developed this technology so that a small lorry and van car can pass through this bridge. The maximum width of the bridge is we have limited to 7.5 feet, because otherwise all vehicles will pass through this, then bridge will fail. If we limit this to 7.5 feet, only a double cab and a small van car can move. Heavy lorries cannot move with this width. And the maximum length span of the bridge is 30 feet. Here we use spaces. The same technology we can use to interconnection of buildings. You know, if there are, this is especially good for school buildings. If there are two adjacent buildings with 4 stories, then the teachers have to travel all this way to go to the other building. Then if there is a bridge like this, then it is very easy. Then there is a manual for construction of footbridges. There are some guidelines given there. We use these guidelines to introduce this technology. The ferrocement technology is very simple technology, cost effective, easily repairable, less maintenance, simple technique, no machineries are required. Ferrocement is a technology used with a lot of labor. This is the section of the ferrocement bridge beam. It is 650 millimeter high, 600 millimeter wide. 2 of these panels, we test this, we cast this panel, test at net center with these loads, and construct these bridges. And we analyze using this SAP also. These are the bridges we constructed. This is at Buttala. The span is 20 feet, width is 4 feet. Only a 3-wheeler can move. This is another bridge at Wahatiyagama Jayala. Then this Spaces concrete footbridges. Spaces, you know, is a well-established system, design codes and analysis methods also available. Center have registered licenses all over the island. Small sections, spaces beams are very small with compared to RC. Site work is minimum, very quick construction. Then this method is very suitable for construction of footbridges. These are the sections, structural forms we have introduced to construct these footbridges. This is 4 feet wide footbridge. This is also 4 feet, and the length is 25. This is another section like that. Up to now we have constructed over 25 footbridges all over the country. These beams are manufactured at net yard, and we cast the bridges here and load tested, and all are satisfied, and we replace this type of bridges, this type of rope. This is a electricity post they have used as a bridge, and we replace this place with this type of bridge. This is we did it in 2010. This is at Meerigama, adjacent to Colombo Kandy Highway. This is at Ratnapura, another bridge we constructed in 2012. This is near Bopatal. In this place, there was no single log to cross the canal. We construct this bridge, then these school children all pass through this bridge. And this is another project we did at Moravaka. This is 7.5 feet wide, 30 feet long bridge. Small van can move using this bridge. Then there are some other ferrocement products we have introduced. Ferrocement water tanks. These water tanks, actually these water tanks cannot compete with this PVC one. but if we can go for a higher capacities, it is economical. This is 60,000 liter ferrocement water tank we constructed for water board at Mahiyangana. This is another water tank for use for irrigation purpose. This is at Kakapalli, Dr. Revjivardhana's land. And we have this ferrocement toilet technology also. These panels are half-inch, and these toilets are good for temporary locations. If there is exhibition or something, you can assemble here. After the exhibition completed, you can remove it from, it is connected with nut and bolts, and you can remove it and you can fix it another place like that. It is very, these toilets are very cheap. And this is the end of the presentation. If you have any clarification, you can raise it now.
Thank you, Mr. Vasantha, for a very informative presentation. I think we are having some academics also with us in the participant, and also we have a lot of students also. I think it's up now. It's up to you, all of you now. If you have any question, I think we can discuss with Mr. Vasantha. I think he has a lot of experience in this technology, I believe. Mr. Vasantha, I would like to ask one question. Now, what's your comment? Now, I think nowadays, now we have this seismic vulnerability. Now we are discussing about all this seismic vulnerability and all these things relevant to Sri Lanka as well. I think previously we didn't had that issue. Now, with your technology, have you studied about that aspect, or it's still are you not studying that aspect? Especially, I'm asking about this. Yeah.
At the moment, we have not considered this effect, but it can be included because the guidelines we can follow with this technology as well. But at the moment, we haven't, because these are medium rise and low rise buildings. We go maximum with this technology. We go maximum 4 stories.
Yeah.
And
I'm asking
if somebody
now, these are precast element. I think then especially I think when you're thinking about the connections, I believe especially under earthquake, maybe there are some concerns. No, I think yeah, maybe we are if you are moving towards the direction, maybe we may have to improve. I think certain details. I believe, isn't it?
Yeah. Yes, actually, this when you design 3-storied or 4-storied building, if there is a lift well,
yeah,
and there are some in situ columns also, because sometimes the middle columns we cannot use this pre-stressed concrete columns because of the load of the middle columns are higher. Then with this combination,
yeah. Then anyway, you have maybe the lateral stability, I believe.
Yes.
Okay. I think students, you can ask if you have any questions. I think you can get a lot of knowledge from our resource person today, I believe. In the audience, you can ask any question, I believe. Also, our academics, I think there are a few academics also attended for the session.
All these technologies are available at NED Center with the actual scale models. If anybody interested, you can visit the NED, and we have some demonstrators as well. They will explain, and you can see physically the technology.
I think maybe we can arrange a site visit for our student. No, if required, it's possible, I believe, isn't it?
Yes. If you officially request from NED, we will allocate few engineers also. You
Yes.
can see our processing yard
Mhm.
and model houses, these retaining walls, footbridges, all of these technologies are available with the actual models at NERD Center. We have a technology park here.
Yes.
You can visit
The
this
future,
technology park
yeah,
and
maybe,
have a good
yeah, maybe,
understanding.
yeah, maybe in the future we may able to arrange some site visit with you. I believe still is it will be very useful for our undergraduate student. I believe because under their construction technology, I think they learn about some of these technology, and maybe with this new technology, I think their knowledge in that aspect may increase. I believe.
Yeah, already the technology faculties from Puliyapiti, Payama University,
Yeah.
they visited frequently.
Yes. Yes.
Noratua, sometimes they also visited like
Yeah.
that.
Dr. Chandana, Dr. Kamal, do you have any comment or any questions? I believe we can discuss with Mr. Vasanta if you have any. Or any other student or any academics. You are invited to discuss with Mr. Vasanta, I believe, if you have any clarifications or doubts or any comments. Now, regarding these retaining walls, Mr. Vasanta, what will be the maximum heights that you normally allowed the construction?
No, the problem is we always think about the manual handling. In this manual handling, we have limited this section to 300 millimeter by 175 millimeter at the bottom, pre-stress retaining wall.
Mm-hmm.
With this section, we can go up to 12 feet.
12 feet.
If you increase the uh, wall width, you can go further. But the problem is then you need machineries to handle these panels. Theoretically, you can go up to 20 or even higher. But we have now we have limited to 12 feet because in some locations we cannot use machineries. This,
Yeah, I think you have done all the design checks, and also I think it's better if you can
yeah,
share that particular article. I think there was a site I believe that there you have checked about the stressors and all these things. I think it will be useful maybe for the student.
everything is checked.
Yeah, can
Actually,
you show that site again? I believe Mr. Shanta, it's maybe a good thing.
which one? Which one?
I think you had a
Which
slide
one?
where it says about the stressors under pre-stressing condition and all these things. In a one
Uh,
slide, I believe, yeah.
that is that is for the post tension masonry one.
Yes, yes,
This
that's
one.
what I'm asking. Yes,
This one.
yes, yes, correct.
Yeah.
Yeah. Now in that case,
This
I
is the masonry block.
correct.
And we process this eccentric. This dark color one is the high tensile steel wire.
Mhm.
And this block is processed eccentrically. This is the centroid of the block.
Yeah,
We process eccentrically. And this side is subjected to compression.
yeah,
This side is subjected to tension. We apply this soil pressure here.
yeah.
And this tension due to soil pressure is balanced by the compression pressure due to this phase stress.
Yeah.
This is the
Basically, you have effectively used the pre-stressing technology to resist the lateral force, I believe there.
yes.
Yes, I think
This
it's a good, interesting design, I believe.
this one actually this phase stress retaining wall and post tension retaining wall both are my own projects.
Ah,
Yes,
okay.
I have published these research papers for these both technologies at the Candy conference. You
Ah,
know,
okay. Yeah, yeah. Yeah, I think it's a very interesting technology, I believe. I think you have done field testing also. I think we have seen that you have checked about this deflection and all these things.
sorry.
You have checked about the deflection also. I believe I have shown. You
Ah,
have
yeah,
shown
yeah,
us
yeah.
PR one picture, I believe.
Yeah. They are, actually, I have. If somebody is interested, I can give you the full.
Mr. Vasanta, can you hear us? So I think have you disconnected? I can't hear from you. Can you hear me? What about other audience? Can you hear us? Hello, can you hear us? So, if there's any problem in the network? I believe Mr. Vasanta has maybe disconnected, maybe due to a connection issue, but we'll see whether we can rejoin us. So, otherwise, I think we may have to wind up the session. Maybe Vasanta may having Mr. Vasanta may having a technical issue. We'll see about few minutes. Anyway, I think he has done a very informative presentation. Okay, I believe Mr. Vasanta may be having a problem in his connection, most probably with this weather condition are prevailing at these days. Anyway, I would like to thank Mr. Vasanta Pereira who shared us his knowledge with us. I think he did a very informative presentation regarding the technologies that are developed by NERD. I think I think we can learn a lot from those technologies, and especially for our students, maybe for their final year projects, especially for civil students for their final year projects, and maybe they can take some inputs from this presentation. I believe definitely they will take some positives out of this presentation. And again, I would like to thank all the participants, including I think Professor Senayaka was also there in the audience, I believe, and there were some other academics from our department as well as from other department. I would like to thank all the academics who joined for this session. I think some of the other academics also plan to join this session, but unfortunately, due to I think there are some other commitments, they were not able to attend the session. Maybe I would like to thank all the students and all other participants who joined for the session. And with that note, I hope we can end the session. I believe Mr. Vasanta may be having. Give me a minute. I think he's calling. Yes, as I said, I think he's having I think he called me and he's having some technical issue in his connection. I think maybe due to this bad weather presently at the in our area. Uh, yeah, with that note, I think I would like to thank all the participants who participated for the session. And I believe that all of you will join us in the hours conference also that will be held in 9th and 10th. That means the Thursday and Friday. And I would like to invite all of you to attend maybe the conference session as well as for the parallel sessions that are especially under engineering technology. Also, we have a parallel session. I hope that especially students who, if you are wishing to attend those sessions, we will encourage you all of you to attend. You can attend physically or online. We will share those information also through the faculty website and our university website. We welcome all on behalf of the ours organizing committee. Okay, thank you very much. With that note, I will end the session.
Thank you, sir.
Thank you.